Incidents happen during mooring.
Movements of a badly...
Hello, and welcome to this program about mooring operations. Why? Well, in fact, a professional mooring operation is a kind of missing link in the overall nautical chain. Today, there is little information on or international regulations available for mooring lines, winches, or bollards. Strange when you consider that a lot of incidents happen during mooring.
Movements of a badly moored vessel can result in expensive damage to cranes, manifolds, or other vessels. A ship breaking loose of its moorings is a nightmare to all ports.
A professional mooring process can not only reduce incidents, it can also save time, money, and cut down on emissions. This video focuses on the main causes of mooring accidents.
95% of the incidents with personal injury is caused by ropes and wires, being hit by a rope. Just 5% is due to equipment failure. 60% of all those rope incidents happen during mooring operations. So, improving mooring operations reduces accidents and personal injuries.
Unprofessional people involved in mooring operations do not see the safety dangers that are actually there, that are existent. They do not know that things have to work together, that the hands have to grip into each other to make a mooring as such a safe operation.
And good communication between the pilots, the captain, and the tugboats is of utmost importance.
Safe mooring starts at sea, with a good preparation and precise calculation of the forces on winches, bollards and lines.
All components come together in the mooring plan, sometimes made up by the terminal, but in all cases the captain is responsible for safe mooring. A professional plan is based on 4 rules.
First, all the lines should not exceed a vertical angle of 30 degrees. Therefore, the horizontal distance from fair lead to bollard is twice the vertical distance. Second, the spring lines should be placed as parallel to the vessel as possible. Third, breast lines are most effective when connected square to the vessel. If the optimal angles cannot be realized, please remember that this will have a significant effect on the mooring system. The last rule, lines should work together. To ensure that the forces are spread over the lines, they should have the same characteristics. So 1 and 2 and 3 and 4, same function, same specs. The terminal operator can file such a mooring plan per IMO number for the next visit of the ship or a sister ship. In all mooring plans, it's very important that the hook or bollard ashore isn't the weakest link, like probably in this situation.
Let's start by taking a look at all the components in the mooring system and which of those components should be the weakest link.
The brake of the mooring winch should always be the weakest component. It's a safety device in the overall configuration, which should render before 60% of the minimum braking load of the line is reached. The bollard ashore or on board should always remain the strongest component of all. It's not common practice on every merchant vessel to continuously review the mooring system and ensure that the winch brake indeed is the weakest link of all the components.
So it all starts with a good calculation. For that calculation, the captain needs reliable information, which should be collected prior to entering port. Remember, safe mooring starts at sea. So let's start with the information on the first part of the mooring system, the winches. As we saw, the winch, and especially the maximum holding capacity of the brake, is a crucial safety component, so vital specifications for the captain.
Figures, all available on board in the winch manual. Crucial is that the maximum holding capacity of the winch brake is tested on a regular basis to ensure that the information on the maximum holding capacity is correct. A recommended rule is to adjust the mooring winch brake to 60% of the minimum braking load of the mooring lines. It's a good practice to stencil results of the test on the winch.
Do not want, because when a line will pass, it will take more than just a line. It will take things from the ship. It might even hit someone and kill them. So the last thing that we want is the line to pass. Hence, render. So it takes to render. That is one major principle you should remember yourself. Remind yourself. That was also very important. Pay attention. Why do we use headlines? Why do we use string lines? Why do we use stern lines? There is a stern headline and stern line. There is a spring line and there is a breast line. Okay, you should know the purpose of each. Tomorrow you will be doing the same. Okay, you should not mix and match. What goes first? What comes off first? What goes first? Spring line. Yes, or breast line sometimes, depending on the type of the ship. Breast lines can bring the ship alongside, pull them inside. That make sure that the ship is alongside the person. Ship does not move like this. Yes, the headlines will check the sway of the ship. Yeah, they're moving like this. Keep it oriented. Yeah, and the spring lines will make sure that the vessel does not move. So all these angles and movements are checked. So we have checked this movement by what? Spring line. This movement breast line by breast line, and this movement by spring line, and this movement by head and stern line. Okay. Every jetty will have, or every terminal will have a specific mooring plan. The one that you saw, that gentleman there before of the harbor master or the port operation. So you will be given a mooring plan. So mooring plan is, if you are given a mooring plan of, let's say, 4, 2, 2. This means 4 head or stern lines, 2 breast lines, and 2 spring lines. So how will this mooring arrangement of 4, 2, 2 forward and aft will look like? This is your berth and this is your ship. Yeah. So you will send out 4 headlines, forward and aft. Okay. And then you will send out 2 breast lines, and you will send out 2 spring lines. Make sense? Yes. Now, why it also mentioned that all of these ropes should be of same type, same property. Why? Because there will, otherwise the distribution of load will become uneven. If I use a steel rope here and a soft nylon rope here, what will happen? This nylon rope will part, and then all the load will come onto the steel line, and this will also later on part. There will be unequal distribution of forces and elasticity as well. Okay? Make sense? So brake rendering load should be 60% of the maximum brake load MBL of the line that you are using. What all kind of lines are there? There is steel wire ropes. Yeah. Then there are nylon ropes. There are polypropylene ropes, and there are special aramide ropes, or you can say newly designed synthetic high tensile strength rope. These newly designed high tensile ropes are just to replace the steel wires. The steel wires are very big, heavy, difficult to manage. Yes, so they designed something synthetic which matches the properties of in the breaking strength of steel wire. The steel wire is really strong. Plus, they are agile to use. But the problem with them is they have to be handled very delicately. Yes. Also, even if every at the end of a steel wire rope, you will see there is a steel wire rope, and at the end of the steel wire rope there is a loose tail. Yeah. Have you seen that? Yes. Why is that? Because the steel wire does not have much elasticity. Maybe about only 2 to 4%. Bit about here and there. It will not stretch much. It will just part later on. A loose rope, if it's a polypropylene rope, it will stretch a lot. 10-20% will stretch. So at the end, you provide a very high, let the steel wire breaking strength was, let's say 100 tons. So you will provide a big heavy loose rope, or you can say a polypropylene rope here, a big thick one, which can then stretch with a, let's say, a breaking load of higher than this, let's say of 150 tons. Why? Because this is going to wear and tear more quicker than this length. Yes? So we'll continue this.
And also mark the correct payout direction. Bear in mind that the results of such a test or adjustment are not very reliable if the winch is not fitted with a spring-applied brake. Something to consider for new buildings. Mooring lines, different sorts, different specs, different prices. But crucial is that the line is much stronger than the winch brake, so the line won't break in extreme conditions.
Where can one find the information about the minimum braking load of a line? How can we ensure that the line has not become weaker? When and how should we order new lines?
As a rule of thumb, take the vessel's equipment number, look up the minimum braking load in MSC Circular 1175 and double it. For example, the equipment number is 3040. The minimum braking load found in this table is 500 kN. So the line should have a minimum braking load of 100 ton, and so the winch brake should be adjusted at 60%, so 60 ton. Each individual line has a certificate that clearly specifies its minimum braking load.
Line on the ship, all these lines, each line have an individual state. When is braking load of this line? When was the line manufactured? Yes, you have to maintain all of these records on the ship.
But the same strength doesn't mean the same properties. Two ropes, same minimum braking load, but different properties. This one, an open structure and easy to check the quality, easy to splice, but also open for rust, sand, salt and sunlight, which may cause damage due to internal abrasion. This rope is more expensive, but has a cover for a longer lifetime, a better shake stability on a winch drum, and is safer when the minimum braking load is exceeded. This test shows the difference. This is how the open structure rope.
What they are going to demonstrate is how much the rope going to flake. Because when a rope breaks, it flakes. That is what kills people, that is what causes damage. A rope breaks and does not flake much. That is what we want. We want to use those lines for operation. Yeah? We don't want to use those lines which will break and they will go everywhere and kill everyone. Alright?
Reacts. The covered line reduces the snapback, so less risks for the crew. But when ordering a line, there is more to be considered.
The elasticity of the mooring line should match the other mooring lines used for the same function. For example, all the breast lines should have the same elasticity. That's the only way all the forces can be equally spread over all the mooring lines. How can we maintain lines optimally? By ensuring that there are no burrs or grooves in the leads. Also, avoid contact between lines and sharp edges and ensure that there are no twists or kinks in the line. And finally, turn the line on the drums end-to-end half-time. Even if the lines are maintained optimally, regular visual checks are important to maintain the quality of the rope.
In case of doubt about the condition, send the rope over to your manufacturer for a check.
Information on the safe working load of bollards and hooks and layout can be obtained via the terminal operator prior to...
Tomorrow we will be doing the berthing exercise in a same terminal like this. Now this thing is called a dolphin. Yes, and your ship goes alongside somewhere over here. Yeah, and this is a shore loading arm, especially a general tanker design, whether it is oil, chemical or gas, always going to be almost like this. Okay, so what happens is this is your headline, your stern lines, the breast lines are somewhere here, and your spring lines will be going somewhere over there. Yeah. What they do is, generally, if it is a bigger ship or whatever is the plan, this is your berth with your loading arm. Yeah. Your ship also has a manifold here with loading arm, and these are the dolphins bring ashore. Yeah, you can see. So your lines are going to go, and then your spring lines will go over there. What they do is, sometimes they will just run your breast ashore. If there are less number of tugs or really half tugs will push the ship. They will bring the ship bodily close to the berth, bring it over here, and then start pushing it towards the terminal. Now, they cannot exactly position this. They have to match the ship's manifold to the shore's manifold, because this is fixed and this is fixed. They cannot move more than a meter here or there. So they want to match them exactly. What happens is they send one person here, ship goes alongside, and then this person tells or advises, or sometimes they have these laser pointers now. They can adjust that how much ship has to move forward and aft before you make all lines tight. So what they do is they bring the ship alongside and they pass on your first line to pass is your stern line, your spring line, and they pass both the springs, and then the tugs keep pushing the ship with, let's say, 5% to 10% of power, keep the ship in place, where the ship can be moved, adjusted slightly. The last bit of slight adjustment of 10 meters here or there can be done once the ship is already touching the fender here. Last bit of adjustment that is done with your spring line. How will you adjust the ship with your spring line? Let's say this was the ship, and this was the manifold, and this was the shore manifold, and you had to fall back by 10 meters. Yeah. So you have run your spring line here, and you have run your one spring line here. The spring bollards are here. How are you going to adjust it? What will you tell your ship's crew? This is the winches here. One person forward, one person aft. Forward, aft. Forward. So you will tell, standing here on the bridge control station, you will tell that you start picking up. Pick up. Yeah. Pick up the forward spring. What will this happen? What will start when you start picking up the forward spring? What will happen? This distance will become shorter, and your ship should start. And at the same time, you have to tell this person aft to slack the rope aft. Yeah. Slack the aft spring line. So they will let go slowly, and they will start picking up, and your ship will start going. And this person standing here in the center will say, "Okay, vessel is aligned," and that time they will tighten both the springs, and then they can start passing all the lines. Make sense? Okay.
To arrival of the vessel. That information is very important to the captain.
Information about the safe working load of bollards or hooks is stenciled on each bollard and hook. And guarantee easy local and remote release of mooring lines, even if they're still under tension. During the stay, the forces on all hooks are monitored.
There's a vital need for good information, an accurate mooring plan given to the captain of the vessel at sea, providing adequate details about the hooks, the bollards, the mooring line positions is a vital part of making sure the mooring operation goes smoothly.
I think that the information a master needs to brief his crew in a professional way necessitates proper information from the port about the bollard distances, about bollard pulls and the requirements of the port. For instance, how many lines can be put onto one bollard. There is room for improvement, but that also requires that the ship sends in the information on their possibilities. So after all, it's again a mooring plan with the requirements which can solve a lot of problems.
Professional line handling starts with a clean and safe working area. Of course, the deck is anti-slip and the working area should be properly lit. The crew should be trained and briefed for the mooring operation.
Ideally, there should be a crew of 3 crew members and 1 officer on the aft and forward mooring station. If this cannot be realized due to the limited manning of the vessel, mooring operations should be well planned and maximum safety precautions should be taken. Not only the crew on deck, but also linemen ashore should be well trained. All mooring lines are prepared for paying out smoothly, so flaked on deck. And even during the preparation, never stand in the bight of a rope. Each crew prepares 2 heaving lines, with a good visible and soft monkey fist.
It has sometimes happened that the monkey fish is of a material as iron or something, and that can not only hurt the boatman or other people on the quay, but it can even kill a boatman on the quay.
Make sure the spring lines are tensioned, so they won't get stuck between fenders and vessel, or even worse, under the fenders. The breast lines are passed from inboard to outboard. And very important, all lines should bear the same tension. During stay in port, spring lines should be on the brake to avoid the ship walking along the quay. Breast lines can be put on auto tension mode. If wind or current is picking up above 4/6, switch for extra safety from auto tension to brake mode, because the brake mode is stronger than the tension mode. Finally, when the ship is leaving, one still needs to pay attention to safety.
During the unmooring operation, it's very important that there is a constant eye contact between the deck crew, first mate and the boatman, because when the rope is unmoored, it is in the water, and then it can come into the propeller, and it can stuck on the quayside, and then you get a critical situation for the boatman as well as the ship.
The nautical sector is an innovative sector, constantly looking for improvement of the entire mooring process to make it faster, simpler and better for the environment.
A good example is the so-called moormaster, based on vacuum techniques. The vacuum pads, operated by one push on a button, keep the vessel in a secure position. Another innovative mooring system without any line handling is based on magnetics. A system that doesn't require modifications to the key and can be used anywhere is the so-called shore tension, a flexible hydraulic standalone system that equals the use of a 60 tons bollard pull tugboat to keep a vessel in a fixed position along the quay.
film, we focused on mooring operations, on the daily practice, and on improvements in the whole nautical chain of professional mooring for more safety, more efficiency, and therefore a shorter turnaround time for a ship in a port. And last but not least, to protect expensive equipment like cranes or manifolds.
We need good information, training and communication, and we need to raise the professionalism around the daily line handling practices.
There always be good communication between the guys on deck, that they are always in direct contact with the boatmen. As always, not only use your VHF, but also use your eyes.
With the increasing number of accidents, which are probably reasoned in the fact that the number of professional seamen are diminishing, the awareness at international institutions has been raised, and I'm confident that there will be respective regulations in the near future.
So there's a lot of work to do, because in the nautical chain, mooring shouldn't be the missing link. Goodbye and good luck.
Hold on. You're making yourself running. Okay, this is for tomorrow. This is going to be your ship, the same LNG ship that I showed you. Yes, and you are going to be given 3 tugs to work with. This is going to be your terminal where you will go alongside. Can you see it? Yes, so your job will be to put this ship alongside using tugs. When we come tomorrow, we will show you how to use tugs, how to use pivot points. Yeah, and that will cover communication as well. This is your dock, this is the terminal, this is another terminal. You will be going alongside in the terminal that is over here. Now, which side you are going to go alongside? Here, port side or starboard side? This is for you to think in the night. I want you to think and come and tell me tomorrow, which side should a ship like this go alongside? Okay, port side or starboard side? You can see your vessel is entering from the breakwater outside. Yeah, earlier today you did an anchoring there, somewhere out there. So you were going to come. I will start your exercise somewhere from at the end of this breakwater. Yeah, tug, and then you are not going to use your engine at all. You are going to use the tug to bring you inside. You can use your engine, but that's slow head maximum, just to move ahead. And then you are going to use your tug to put yourself alongside. Now I want you to think which side you will go alongside. Port side, starboard side. Starboard side. Think and tell me tomorrow. Alright?
What is the terminal here?